programmers, ever asked yourself how recursion can simplify the complex programs in C? Well, today we are tackling the challenge of finding factorial of a number through recursion. So let's get started. As you all know, I'm Preeti. I'm a first semester computer science and engineering student at Sri Venkateshwara College of Engineering, Bengaluru. So before writing a C program, let's see the table of contents of this session. Today we are going to learn about the definition of recursive functions and the logic behind calculating factorial of a number using recursion, and then we start writing a C program to find the factorial of a number using recursion. Then to have a clear picture about the program, we will have an explanation and flowchart of it, and finally we will execute the program and see the output. Recursive functions. Let's try to understand this concept in a much simpler way without having long definitions. A recursive function is a function that calls itself. Every recursive solution has two major cases, that is a base case and a recursive case. The base case is the condition to stop the recursion, whereas the recursive case is the part where the function calls on itself. I think you might be wondering what are these base and recursive cases? Well, not to worry much. Let's take an example of finding a factorial number to understand this concept in a much better way. Before writing a C program, we must have a clear picture about the logic, right? So let's look into the logic here. And by the way, what is factorial? A factorial is a function that multiplies a number by every number below it until 1 or 0. Because the 0 factorial is 1, right? So if n is equal to 0, then 1, which means the factorial of 0 is 1. If n is not equal to 0, then else part will execute, that is n into n minus 1 factorial, where n must be the positive integer because the factorial of a negative integer is undefined. Now let's take an example where n is equal to 5. 5 is equal to 0, the condition becomes false, so the else block will execute, that is 5 into 4 factorial. And again 5 into, here our n becomes 4, so even 4 is not equal to 0, again the else part will execute, that is 4 into 3 factorial. And now 5 4s are 20 and our n becomes 3. Even 3 is not equal to 0, again the else part will execute, that is 3 into 2 factorial. And now 20 into 3, that is 60, and our n becomes 2. Even 2 is not equal to 0, again the else part will execute, that is 2 into 2 minus 1 factorial, that is 1 factorial. And now 60 into 2, 120, and our n is 1. 1 is not equal to 0, so again the else part will execute, that is 1 into 1 minus 1, that is 0 factorial. 120 into 1, that is 120, and our n becomes 0, so 0 is equal to 0, the condition becomes true, then the function returns 1, which gives us 120 into 1, that is 120. Here the base case is n is equal to 0. As we know, the base case is the terminating condition. Suppose if we are not specifying the base case in this function, then the recursive function would call itself indefinitely and it results into an error called infinite stack. And the recursive case is, that is the factorial is equal to n into n minus 1 factorial. I hope now we are all clear with the definition of base and recursive case. Now let's implement the logic here and write the C program to find the factorial of a number using recursion. Every C program starts with the first statement, that is hashtag include stdio.h, where stdio.h is header file, which stands for standardized input output header file. Now we'll have the function declaration. I hope you remember the result where the factorial of 5 is 120 and 120 is of integer type. So now we are giving the return type as int and the function name as fact and the argument value also in the form of integer, so int. It is int fact of int. We know that the execution starts from the main function, that is int main of open curly bracket. Now let's declare a variable n, that is int n. Printf, enter the number. Here we are seeing a user to enter a number. We observe that there is /n. /n represents the escape sequence character and it is a non-printing character. /n represents the new line. And now we have to intake the value given by the user. This can be achieved with the help of scanf statement, that is scanf %t, ampersand n. Percentility is one of the format specifier and it is specifically used for the integer value. If the user has entered a number less than 0, then we have to print factorial of a negative number is not defined. If the entered number is equal to or greater than 0, then we have to proceed with factorial computation. And this set of statements can be written as if n is less than 0, printf factorial of a negative number is not defined. Else printf factorial of percentile d. Here percentile d is the value of n, that is the number entered by the user, is equal to percentile d. This percentile d refers to the factorial result which is stored in fact of n. Now the function is called. So whenever the function is called, it is transformed to the function definition. Now let's look into the function definition part. We know that the return type is int, that is integer type, and function name is fact and argument value, that is int n. We also know the logic behind finding the factorial of a number. So let's implement here. If n is equal to 0, then we are going to return 1. Else, that is if n is not equal to 0, then we are returning n into fact of n minus 1. And this is how we are going to write a C program to find a factorial of a number using recursion. Now let's quickly understand how does the program work. We are going to enter a number 3. Obviously 3 is greater than 0, so we have to calculate the factorial. When factor of n is called, we know that it jumps to the function definition. So let's see what exactly happens in the function definition. Here n is equal to 3, so we get int fact of int 3, and 3 is not equal to 0, so the program returns 3 into fact of 2. Now again int fact of int 2, even 2 is not equal to 0, so the program returns 2 into fact of 1. Here we get 3 into 2 and fact of 1. Now again int fact of int 1, even 1 is not equal to 0, so the program returns 1 into fact of 0. Here we get 3 into 2, that is 6, 6 into 1 fact of 0. Now again it checks the condition for int fact of int 0. 0 is equal to 0, so the condition becomes true and it returns 1. So we get 6 into 1, that is 6, which is a factorial of 3. Here is the flowchart of the program. Let's revise the program once. So first we are going to read n, and when factorial of n is called, it jumps to the function definition part where the condition for n is checked, that is n is equal to 0 or not. If yes, then fact is equal to 1. If no, then fact is equal to n into factorial of n minus 1. This process continues until n becomes 0. So after it returns fact, we are going to print fact, and finally the program stops its execution. Now let's run the program here. Enter the number. We are going to enter 5, and the factorial of 5 is 120. Let's check for another output. And now we are going to enter a negative number, that is minus 5. And we get factorial of a negative number is not defined. I hope you are all clear with this program. And this is all about today's session. Thank you for watching. Please do like and share the video.